Today's tutorial is about MOPs Camera Blender. This node is all about mixing up cameras. You can input several different cameras and blend smoothly between them, then add camera shake, physics simulations, filtering, or even modify your camera's attributes and SOPs. There's a lot you can do with this node. At its simplest, the MOPs Camera Blender will take any number of input cameras and automatically try to draw a smooth path between them. The output camera will inherit not only the original camera's transform attributes, but their camera attributes as well, things like focus distance, focal length, aperture, and so on. If you're using a third-party render engine like Redshift, you can optionally add the name of any camera parameter to the extra attributes list, and the camera blender will blend between them. It even interpolates animated cameras. The camera blender has built-in options to add camera shake, procedural lag and overshoot, channel filtering, and even simple physical simulation. You can use these to help smooth out difficult paths or to add visual interest for a more cinematic look. The real fun starts when you export the path. You can automatically merge the generated path into a new SOP network that will then be read in by the camera blender. From inside that network, you can do anything you want to the curve, deform it, blur it, or even add waves. The attributes you modify will be read back in and used to transform the camera or to set its attributes. We'll start with some really simple camera blends and then work our way over to the weird stuff. All right, let's start setting up our scene. I'm going to drop down a pig head. And let's start with our first camera. So I'm going to put this first camera back here somewhere, make sure that's aimed at the pig head. Maybe move it off to the left here. Let's split the view so I can actually see both of these at the same time. I'm going to just set this to cam 1. Move them back a bit more. Okay, that looks good. Now let's make our second pose. I'm just going to duplicate that camera and then swing this guy over to the right. Let's look through. Yeah, sure, good enough. Okay, now let's drop down the MOPs Camera Blender. When you first create it, it's going to build this camera for you automatically that's attached as a child camera. All of these settings are already pre-configured to blend whatever camera settings go into it. So focal length, aperture, resolution, all of this stuff comes from whatever cameras are input. I'm just going to rename this to make it easier to see in the list. We're going to call this blend cam. And then let's wire in these first two cameras. So you can see right away what it's doing is building this path that is a red line that gradually fades to green. And this is how you sort of see over time where it's going to go. And if you click on the camera blender, one of the first parameters that you see is blend. And if I just drag from left to right, you can see the camera blending from one end of the line to the other. And that's generally how the animation works on this. So let's set this from cam 2. Let's set this to blend cam. Drag this across again so you can see how it interpolates. It's essentially a linear interpolation just from one end to the other, smoothly blending transforms. So to make this easier to debug, I'm going to set my frame range here to 72, and then on frame 1, I'm going to key here, and then on frame 48, I'm going to key again at 1. So now I can just scrub the timeline and see this thing moving back and forth. So this works, but it's really boring. Let's try adding another camera. Camera 3, I want to actually go in between these two. And so I'm going to, actually before I wire it in, I'm just going to move it into a position maybe between these two cameras. So let's switch this guy to cam 3. And maybe I want it to be back here somewhere. And let's raise it up just a little bit to make things more interesting. Okay, so now I'm going to wire this in, and you can see that the line is not going the right way, and that's because the inputs are out of order. So I need to scroll all the way down on the camera blender and pop this guy up, and now we get the correct order. So if we animate this again and switch this back to blend cam, you can see that the interpolation isn't perfect. There's like a little bump in here in the middle. As far as the algorithm is concerned, this is mathematically correct. It's just linearly interpolating from 0 to 0.5 here, and then 0.5 to 1 in between these two camera transforms. But that's not necessarily going to get you a look that you want. You can see that the camera is kind of swinging down here, and then there's a sudden bump as it goes back up here. The reason for this when you have 3 cameras is because the camera blender internally is trying to create a Bezier. And you can't create a smooth Bezier with 3 points. You need 4. So if we only have 3 camera poses, and we know we need to blend between them, there's a couple of things that you can do. One of them is to enable smoothing. When smoothing is on, you can see that it's going to start, literally smoothing this path. And we can turn up the number of blurring iterations to soften this even further. The advantage of using the smoothing setup here is that you're going to get a nice clean move here, although there's still a little bit of jank in the orientation, and I'll talk about that more in a second. But the downside is that you're not going to be able to accurately match 100% the pose of every single camera. Sometimes that's not the most important thing in the world, but in some cases that can really mess up how you wanted to align these cameras. If you really need to match, then smoothing like this isn't going to be an option. You could try and remove P from the attributes that you're smoothing, and that'll smooth out the orientation without smoothing position, but that's also still not going to get you exactly what you want. You can see there's a little bump there. So I'm going to set this back to the default, and then let's disable smoothing temporarily. And I want to add a fourth camera just to show you what I mean by this Bezier. So I'm going to move cam 3 over just a hair. And then cam 4, I'm going to move maybe over here somewhere. So now I've got this sort of raised path in the middle. I'm going to wire this in, and then again, I need to reorder the cameras. So now I've got this arc, and you can see right away, now that it's got 4 input points, the Camera Blender can automatically interpolate between all of them. But you can see that there's still something weird going on when it does these transforms. The reason for this is that a linear interpolation of the camera, including both the rotation and the translation, isn't necessarily going to keep this camera on target. You can see, if I graph this, that the pivot point is constantly wobbling back and forth because it's not being considered as part of a linear interpolation of the camera transforms. And that wobble manifests in the blend cam over here. The way that you can deal with that is by enabling maintain focal point. If I turn this on and then click back on the blend cam, what it's going to do is it's actually going to do this same kind of interpolation, but it's going to be doing it on the pivot points of each of these cameras. And by pivot point, I mean essentially the direction of the camera plus the focal length, or the focus distance. Sorry, focal length is different. But you can see already that with this activated, the camera move appears much smoother than it did before. Okay, now let's go back to that 3 camera setup. I'm going to take camera 4 here and just disconnect it, and then let's move camera 3 back towards the middle. Now, one other trick that you can use if you have a path that you're trying to smooth out is when maintain focal point is on, what you can do is also maintain distance. And you can see that as soon as I turn it on, I'm starting to get an arc. What it's going to try to do is based on the focus distance of each of these cameras, so cam 1, cam 3, and cam 2, it's going to try and maintain that distance as well as maintaining the aim on the target. So now if I drag this across, you can see that it's a lot smoother than it was. There's still a bit of a hiccup there, but you're getting much better results out of a 3-point camera setup. And now if I wanted to, I could go in here and enable smoothing and maybe tighten this up just a little bit. And now I'm getting a pretty smooth camera move out of just 3 points. Now, if it's really important that your cameras are exactly 100% on target, but you still need to do this smoothing, you have an option here to anchor the original points. When you turn this on, you can see that some of these points are going to jump a little bit. This is because it's going to try as hard as it can to anchor the points so that when we're halfway through this move here, in fact, I can just sort of scrub into position here, it's going to hit that target 100%. It will match it. But you risk having a slightly bumpier camera when you do this. You can see there's like a little jump here that we might need to possibly even add even more smoothing or less smoothing iterations. Sometimes it's a bit of a balance to try and find how you can get that target 100% and also get a smooth path. It's not always the easiest thing to do, especially if you only have 3 cameras and you can't get a smooth Bezier. If you're dealing with a really specific situation and these controls don't seem to be doing it for you, you have one more option, and that's to actually export the path to an external SOP. When you click one of these buttons, what it's going to do is take this path that you see here and actually merge it into a new SOP network. So it's going to name it after your camera blender and then just put the path suffix on it. And you push this button, what also happens is the camera blender will turn off show camera path and then turn on use external path and then point it to this path SOP. If we actually go to the SOP network here and then click on this path, what you're going to see is a whole list of points with attributes that correspond to the different camera attributes that are being controlled. P is obviously controlling the position, and you have N and up that control sort of the directionality of the camera. along with resolution, ortho width, the clipping planes, all of those other camera parameters that this thing controls. So you could actually go in here and run your own smoothing setup on this. So I could just put in maybe a smooth node, tell it to smooth all attributes, and maybe turn the filter quality down if I need something really smooth, and play around with this, maybe experiment a little bit to try and get a smoother path. And then when I jump back out, this thing will actually be following that path that I generated. One last parameter that I want to show on this first tab of the camera blend is the blend mode parameter. So this defaults to normalized, which means that when you have a value of 0, you're at the beginning of the path, and when you have a value of 1, you're at the end of the path. But there's another interpolation mode you can use that's especially handy if you have a lot of cameras and the number of them matters. If I switch this to camera index, when I blend from 0 to 1, where my keyframes are, you can see that 1 lands exactly on the second camera. What camera index means is that if you blend to camera 0, you're on the first cam, 1, you're on the second cam, and so on. So the exact distance along the path depends on how many cameras you input. If I go to this keyframe here and set this to 2, and then set this as a key, you can see that now I'm actually translating across the entire path. So if you have a lot of input cameras, this can be a really handy way of making sure that you're hitting the right camera on the right beat. Okay, now let's jump over to the next tab. These are the camera shake controls. If I enable camera shake, by default, what this thing is going to do is add, well, what's in this scene, a crazy amount of camera shake based on the position of the camera. So this is a position-based function, and that means that the camera is going to shake anytime it moves. You have an option to mask the shake by speed, which, and just based on the scene scale, I'm going to set the minimum and maximum speed to 5 and 10. When this means that depending on the speed of the camera, as it moves, it shakes depending on how quickly it's moving. So at the beginning, there's not much shake, and then it rattles quite a bit and then tapers off towards the end. This is the simplest way to get camera shake, but there's not a ton of control over it. If I instead want to be really particular about what I want the noise to look like, I can go over to noise properties, and then this will look familiar if you used any of the noise functions in the rest of MOPs. What I can do is enable use rest attribute. What this means is that when I scrub the timeline now, it's not necessarily going to know what to do because the noise function is looking for a rest attribute that doesn't change. It's no longer position based. Instead, what we want to do is make the noise time varying, and then let's just crank the scale so that we can see it more obviously. And this means that the noise function is going to evolve over time. If we go back to the shake options here, we can then also introduce something called the shake time delay. What this means is I can say 12, and this means that it's going to delay the onset of the shake by about 12 frames. So now it's going to start moving slowly, and then the shake starts happening afterwards, and then once we reach the end point, even at the very end, it kind of carries some momentum and finishes shaking right here. So this can be useful depending on exactly how physical you want your camera to behave, whether you want the shake to be happening right away, or if you want just a little bit of delay before that kicks in. Okay, let's turn off camera shake for now, and then we're going to skip over to the filtering tab. The filtering options allow you to apply chop filters to the output camera path. If I enable filtering and then turn on channel smoothing, what you're going to see right away is that the interpolated camera kind of moves inwards a bit, and that's because the entire path is being smoothed over temporarily. So you can see it is very smooth, although the disadvantage of doing it this way is that you're not going to have any way of 100% matching these targets. The more you drag down the effect or the filter width, the closer you're going to get to the source curve, but it's never going to be 100%, and you don't have the option to actually anchor these, but it can be useful in filtering out a really difficult camera move. If you just can't get the path to be smooth enough, especially if you have a lot of cameras, this can sometimes be a way of smoothing all of that out without as much fuss. I'm going to turn this off for now, and then let's jump over to the lag and overshoot options. Lag and overshoot are interesting in that that parameters are all derived straight from the lag chop, and they're a little bit confusing, but essentially the reason that they're paired up is that you have different amounts of lag and overshoot that you can apply based on whether a channel is increasing or decreasing. Most of the time you can just leave these paired up. So the amount of overshoot right now at 0.5 means that this thing is going to, and you can already see it kind of missing the path here, it's going to sort of shoot past, and then almost like it's attached to a spring, it's going to try and contract back. So you can see that at the end, it's going to do this little bounce. And the higher this value is, the more of this bounce you're going to see. So if you want this camera to look really physical, we can go up to 1, and you can see that it bounces around quite a bit at the end. Let's just turn off overshoot for now and check out the lag channels. So lag is an interesting one in that it's almost like applying a drag force to your camera. If we just do 0.5, 0.5 on this, you can see that the camera, it starts moving, but it's kind of just barely missing these points that it's supposed to be hitting, and then it sort of eases very slowly into the end point. It's almost like it's underwater a little bit. You can, if you're scrubbing the timeline, you can almost feel that drag happening. This is sometimes good also to smooth things out or to add like a little bit more physicality to the camera. Although if you start getting really high values of lag, you're going to end up with a camera that's really hard to control. So it's going to just kind of move as if it's moving through sludge, and it's also going to have a hard time sticking to the camera path. But it's here because you can sometimes get some really interesting effects with it. I'm going to turn this off. The third filter here that I skipped over is the Euler filter. And this is essentially just a chop that if you are using Euler Interpolation, if I go back to the camera blend here, you have an option to use Euler Rotation instead of Quaternion. I recommend against it, but there are a few situations in which you might need to use Euler rotations. If you're using a camera that is doing barrel rolls, it's doing a lot of 360s, Quaternion interpolation doesn't really understand that. It's not going to be able to interpolate between cameras that are constantly spinning around over an axis. And in that case, you might need Euler interpolation so that it can actually accomplish that full spin, because Quaternion interpolation is always going to take the shortest path between two cameras. If you need to use Euler interpolation, the Euler filter option is here essentially to try to avoid gimbal lock. It's not always going to fix it. Euler interpolation is very finicky, especially for something that is as tightly aimed as a camera, but it's here as a backup in case you can't solve it any other way. Last thing I want to mention about filter options is that because they're chops based, chops needs to evaluate your entire timeline at once anytime any kind of input channel changes. And that means that they can be very, very slow if you have input data that's changing in any way. The way to avoid this and get good interactive behavior is to enable caching. So just as an example, if I start scrubbing the lag or overshoot parameters here, you can see that it's hiccuping a little bit. It has to recompute all of this stuff every single time. And even for a single camera that's just blending 3 transforms over a period of 93 frames, or I guess 240 if it's computing the entire range, it's still choking on this a bit. So to get around this, if you scroll all the way to the top, there's an option to cache the blended path. All this is going to do is just store the path in memory up to, whatever number of frames. It doesn't really matter that much. And now if I scrub the overshoot values, it's almost instantaneous. It's much faster than it was before. And now I can actually dial these things in and get really clean results. Just don't forget after the fact, if your cameras are cached, you may need to clear this or disable it once you're done tuning things. Once you're done, it's going to recompute once more. But then if you're not changing anything else on the input, it's not going to have to do it again. Okay, let's disable filtering and then jump over to the physics settings. When you enable physics, what you're doing is attaching the camera to a spring. It's going to try to follow the goal camera that you originally set, but it's going to miss a little bit based on the stiffness and damping settings. Let's just play this right away. I'm going to reset the sim and then hit play. And you can see that there's a little bit of a jitter at the end. You can kind of see it on the camera here, and it's a little bit more visible in the pig that you get this little bounce. You don't notice a ton, and this is mostly because the stiffness of this spring is fairly high for this scene scale. I want to emphasize that because this is a physical simulation, the scene scale is really important, and it's hard to give you default settings that are one size fits all here because it's really dependent on how big your scene is. So for this, if we want to get, a little bit more sway, this stiffness is probably too high. So I'm going to drop this to 2 and then reset the simulation. And you can see that now we're getting this pretty defined bounce as we move across the path. It is wiggling a lot though, and you might not want it to wiggle that much. The stiffness control basically says how tightly is it bound to the original position and orientation of the camera. And the damping controls energy loss. So by lowering the stiffness, I'm making it bounce a little bit further away. But if I want it to sort of reach the goal position more quickly, I can increase the damping ratio. So if I turn this to 0.5 and then reset, you can see that it swings just about as far away as it originally did, but it reaches this rest position much quicker. I can take this even higher, and it starts to get kind of muddy. It like hits the position, swings out a little bit, and then almost immediately bounces back. Similarly, if I turn the damping ratio really low, like 0.02, it's going to hit that position and then kind of bounce forever. It's going to oscillate quite a bit. So let's say you only want to affect translation, or you only want to affect rotation of the camera, and you have these different settings here. The way you can do that is basically by cranking the stiffness and the damping for one or the other. So if I only want rotation to be affected by the springs, if I set my stiffness to something like 20 and the damping ratio to 1, and then leave on angular stiffness, what I'm going to get out of this is only the angular component of this. So you're really only going to see a big bump in the middle here because the camera's pitch is changing. And at the end, you hardly see anything. There's like a little bit of a bump there. If I were to do the same for the angular stiffness and crank this all the way up and then increase the damping, you're hardly going to see anything at all. There's really no spring movement at all. Now, maybe if I only want this to be controlling the position, I can leave the angular stiffness high and then dial this back down. Just to show you what the angular stiffness looks like by itself, if I drop this down to, say, 1 and then bring the ratio down to something more reasonable like 0.2, you're going to see it's going to sway quite a bit. And this is a very different kind of camera shake than the positional shake. So there's reasons why you might want to use one or the other, but it's really more of a directorial choice. It's whatever kind of motion looks good for your shot. Just a couple more important options to go over here. At the top of the parameters list, you're going to see Generate Linked Camera and Bake Linked Camera. First, the Bake button is if you need to get this camera baked to keyframes in case you want to export it to Nuke or Unreal, or in case you have a limited number of MOPs Plus licenses and you need to get this working on a render farm, or if you're using the physics options or something else that's non-deterministic that way, and you need it to be baked to keyframes, this button will just really quickly take your camera and spit out a baked camera. So all of the channels that you generally care about on the camera are going to be baked. But let's say you're using something a little bit more exotic. Maybe you're using some of these Redshift settings. So if you go to Redshift Camera, DOF, enable this, and I want to use like the custom Redshift focus distance setting. If I hover over this, the parameter name is RS Cam Pro DOF distance, which is going to be really fun to type in. But let's say I want to bake that. If I want this to be baked, that means that I probably want it also to be interpolated along the path. So I'm just going to delete this really quick. And on the camera blender, I'm going to scroll to the bottom, and there's a field here called Extra Camera Parameters. If you have any of these non-standard camera parameters that you also want to interpolate, you can add them to this list. So I'm just going to paste that parameter in. And now this is going to be added to the list of attributes that the camera is interpolating. And actually, if I go into this camera path, because this thing is still here, and click on this, you can see that that attribute does exist. And it's the same for these cameras because I haven't set it up, but you can interpolate any attribute of a camera this way. Now, I've got this added to the list and I've got this attribute, but when I click on the blend camera, if I go to the Redshift camera settings and go to DOF, you can see that this isn't driven by anything. And that's because I just added this to the camera blender list and the expression hasn't been regenerated. So in order to fix that, I can actually just delete this blend camera and click Generate Linked Camera again. And now I'm going to rename this blend cam. And now if I go over to my Redshift camera settings, over to DOF here, you can see that the focus distance is actually connected. Generally, you know what attributes you want to blend at the beginning, so you probably want to configure this before you have to start regenerating your camera, because obviously that means you have to rebuild these connections. Now that that's settled, if I scroll back up here and bake the camera again, and then check the Redshift camera settings, you can see that this is actually a Bezier now, so this channel is keyframed. Okay, now we're ready to get into some fun stuff. So here I've set up a new camera move that is pretty difficult. If I scrub from one end to the other, you can see that it's, really having a hard time in the middle here. And even if I enable maintain focal point, you can see that it holds up pretty well, but when we start doing this transition between the third and fourth camera, we kind of lose the target a bit. Now, granted, this is a pretty extreme camera move, but we don't want to lose sight of the pig head in the middle of this motion here. We want to stay focused on target. And despite any amount of smoothing or maintaining the focus distance or anything that I might do to make this work, it still might not be perfect when I'm interpolating between these two cameras. But there's still other stuff that you can do to fix this. But it's going to take some SOPs work. So I'm going to scroll back down here to the Export Path to SOP button. When I click this, again, it's going to export my camera path to an external SOP that's then being referenced by the Camera Blender. So any changes that I make to this path are going to affect how the camera interpolates. Now, I want to make sure that this thing in between these two moves here is actually looking at the pig head. And what I'm dealing with here are points, and these points have orientations. They have N and up attributes. Well, what changes those attributes? Among other things, MOPs. So if I want all of the points along this curve to be aimed at something, an obvious choice would be MOPs Aim. So I'm going to drop this down, and then in order for aim to work, I need to provide a target. So I can just merge in that pig head. And then if I want to look at the center of it, I can just pack the pig head to get a single point at the centroid. I'm going to connect that in as the aim target. And now if I look through this camera here, you can see, if you look closely, that the camera is actually facing directly backwards. And that's because by convention, cameras aim down the negative z-axis, and MOPS by default is aiming down the positive z-axis. So if we switch over to the orientation tab here, and then click Invert Aim, and this is on MOPS Aim 1.2, which is relatively recent. If you have an older build of original MOPS, you might want to consider upgrading, or these controls are going to be in a slightly different order. Now when I scrub the timeline, you can see that it's always staying on target. It's exactly 100% locked on to the center of the pig head. But you're going to notice here, if you look closely, that we're no longer matching our original camera transforms, which can sometimes be a real downer. We're really careful about picking these original poses, and we don't want to lose them. Well, because we're using MOPs, we have access to the entire Falloff system. So if I use a Spline Falloff, and connect it here to the input curve, and I'm just going to connect it as the input for both of these inputs. If I set the mode to, under spline here, to curve position, this is basically just going to sample the curve and then return that as fall off. So if I preview the fall off here, you can see that the curve is just going from purple to white, and that's our fall off ramp. But I can remap this. If I go to the remap tab and enable fit, I can remap the fall off so that it starts at the beginning of the curve with a pretty low value and then stays aimed throughout that problem area and then tapers off at the end. So we're going to definitely hit our starting and ending cameras. And so now if I zoom out here a little bit and start at the very beginning, my camera is 100% dialed in. It's then going to blend that aim in over time. So by the time it hits here, it's 100% locked onto this camera. And then it's going to stay locked on during this problem move and then slowly ease out into the original final position. Maybe I don't want to even blend it in this far. Maybe I only want to lock it in during that problem move. And so I can just adjust the fall off so that only during that really tough area do we actually see this thing blending into aim. And then for the rest of it, we're getting our exact earlier camera moves. You're going to have a little bit of an interpolation hiccup here, so maybe we don't want it to start quite that late. But you can see how powerful this is. We can use any MOPS node, or really any Houdini node at all, any SOP you can think of, to influence both the position and the orientation of the camera. Thanks for watching, and see you again soon.